Hello, I'm Steve West from the dairy team at AHDB and welcome to this evening's webinar. Tonight is the final session of a series of 3 maize-focused webinars. We'll be talking about harvesting, ensiling and feeding maize this evening. The session is being recorded and we're aware that this becomes much more relevant later in the year, so you will be able to refresh your memory nearer the time on the points that we're going to make this evening. So tonight I'm joined once again by John Morgan from Creedy Associates, and he's also representing the Maize Growers Association. We have Joe Carter. He is our AHDB strategic dairy farmer from Chippenham, over in Wiltshire there. And we're joined by Hefin Richards, who is an independent nutritionist at Rumination, who will be taking us through some of the considerations we must all make when feeding maize. We have a dairy farm in focus tonight, but the principles we will talk about are relevant to all. So anybody who wishes to optimize their feed value from maize, this will be relevant to you. I must make particular thanks to Joe's nutritionist, Roy Eastlake, who unfortunately was unavailable this evening, but he's kindly provided some of the data in insight to help us. So Roy is currently working for himself, but was formerly with Lalamond and still consults. So just to take you through a little bit of housekeeping, we'll move to the next slide. All attendees will be muted, so don't worry, nobody can see you or hear you, so there's no problem there. Continue to drink your tea and eat your dinner. We're looking to take this webinar right through to 8:30. We will have plenty of time for questions at the end, so do put your questions in there. I've mentioned that we're going to be recording this, and we'll make that available and send it to you after the event. You'll get emailed a link. There'll be a short survey at the end, so please do fill that in. It really helps us to shape our offering to you. And there is onto the next slide. If you want to ask a question, those of you who've been on webinars before, you'll have done this 100 times before, but you'll see an orange arrow. If you just click on that, look down till you get to questions. Once you tap on that tab, there's a place for you to ask your questions there. Only we see them. They're completely anonymous. There's no such thing as a silly question, so please just put any questions that you want to know the answer to in there, and we'll endeavour to answer those toward the end during the panel. So it would be wrong of me not to mention that all levy payers will have the opportunity to vote on the way your levy is invested within your respective sectors this spring. You must register in order to do this. And the deadline for registration is the 31st of March. I must warn you that you will miss out on this if you've not registered. There won't be an opportunity to retrospectively do it, and it just takes 1 minute. So I would really urge you to do that. And to register, you simply need to go to the Shape the Future tab on our website, but you can simply Google AHDB and Shape the Future to find the link there. As it says there, it's not a vote on whether levy is collected, it's more a vote of exactly how you want the allocation of levy to be invested. So if we move on to the next slide. Oh, there we go, no, we're on. Right. We must get back onto the subject of maize. I've taken enough of your time. So I'd like to draw on our first speaker, John Morgan, who's going to recap on some of the principles mentioned earlier in the series. All of those webinars have been recorded, so please do go back and watch those. But I'll hand over to John, who should be able to share his screen to take us through some of the messages already received.
Thanks, Steve. I'm looking for that link to allow me to share screen, but I'm sure Brian is on the case, unless I've missed something. There we are. Yeah. Okay.
Bro.
So hopefully you can see. Am I right, Steve? You can see the main slide rather than the note slide. Is that right?
Not quite. I think we might be looking at your joining link. Is it the other screen?
Let's have a look.
That's
Stop screen sharing. Why is that doing that then? What can you see now?
the same thing, I think. And if that's
What am I doing wrong there? Apologies.
don't worry. Apologies for all listening.
Why wouldn't it do that then? I did it earlier on when we tried it.
I wonder if.
What have we got now?
No, we've still got the same thing. And if everyone's seeing what I'm seeing, I wonder whether.
Well, have you got the slides there, Steve? Do you want to work through them? Is that possible? Did I send them across or?
I think you just click on your PowerPoint, John. We've got your screen, not your PowerPoint screen. PowerPoint, it should.
Yeah, I thought I was on that one, Jane, but let's see what's.
1 second.
Should change presenter now. What am I doing wrong? If I stop sharing, Brownie, perhaps can we try that again? I'm not quite sure what the.
By all means, share my screen, and I've got it.
Okay. Do you want? Yeah. If you do that, then we'll work from that one, Steve.
Let's do that. How's that? Are we seeing my screen here?
It looks like I am anyway, so that's good. Okay, apologies, folks. Hopefully you can see the screen there. So yes, as Steve said, John Morgan, work as an independent consultant, but also heavily involved with the Maize Growers Association. So my challenge this evening really is to summarize a few of the points that we've talked about at previous webinars the last couple of weeks. And as Steve said, they're all recorded, so they're available to take a look back at. So I won't dwell on these too much. But I wanted to start off by really reminding everyone that maize is a fantastic crop. Animals love it, the consistency, they like it. It's a great crop for digestion. It's the most gaseous crop there is out there, which is why it's the biggest crop used in digestion. It's got low agrochemical use, virtually no fungicides. It's very good at using manure nutrients. It uses very little bagged nutrients. The list is not quite endless, but it's pretty impressive. So it is a great crop. Unfortunately, it does have some challenges associated with it. And those challenges I tend to best summarize in terms of the challenges associated with wet harvest and the challenges associated with what I call nutrient overload. Steve will, I think if Steve moves through to the slides, we can, okay. So the challenge really associated with wet harvest is in my mind very much related to the structure of the soil and the strength of the soil. So this graph here is showing the kind of annual rainfall of a typical part of the UK. It happens to be the southeast England, but I can promise you that graph would be the same throughout the country. And what it's really showing is that through the summer we've got pretty low levels of rainfall, but then comes October it all changes and we start, on average we start getting much heavier amounts of rain. Soil becomes very weak, soil can't take the heavy machinery, soil structure is compromised, and we end up with compacted soils and runoff and flooding and soil wash and soil erosion. And that soil erosion will, if it ends up in the river, as shown in the next slide, you in effect take with it agrochemical, if there's you take it with it nutrient, and you end up also silting up kind of gravel beds and the like. So it's just bad news, and what we want to avoid that if we can. Second of the two challenges was what I've called nutrient overload. Maize, it's a really good user of manures, and it's a fantastic crop to use them because its nutrient uptake is very much in line with the uptake of, the breakdown of organic manure and the release of that nutrient. So it's incredibly effective, but it also provides an opportunity for over application. I think historically, it's fair to say that we've historically applied more than we perhaps should pre-maize. So the next slide really talks you through that, talks us through the nutrient management planning process, where we're trying to balance input and balance output. It fundamentally revolves around soil analysis, which we're all obliged to do now in terms of the final rooms for water, but it's probably some of the best £12 you'll spend per field to start on a good foundation. We then we need to look at crop recommendations, and we need to use manure and fertilizer as appropriately as possible. So we talked through that on one of the previous webinars. We then moved on really to talk about site suitability and particularly variety, the most appropriate variety. So we talked about a risk assessment where we scored a field based on harvest date, drilling date, aspect, soil characteristics, and so on. And we ended up with a score that allowed us to go and choose the most appropriate maturity variety for that field. We talked a bit about drilling dates and the importance of maximising the growing season by getting the maize in the ground as soon as temperature and soil conditions allow, from kind of mid-April onwards. I'm reminded folk that we're a month away, we're quite close to the longest day if we don't drill maize till the middle of May, and we're a long way away from it in the middle of October if we're trying to make up for heat units that we lost in the spring. So we talked about the importance of early drilling, and that photograph there highlights a month difference last year in drilling, and that was translated all the way through to the final harvest, which was the maize was a month late in terms of maturity. Soil temperature is one factor to get maize drilling, but soil conditions are the other. And we talked about the ideal seed bed, which will have kind of fine soil around the seed. It'll have good structure below the seed to allow the roots to really expand and grow. We talked about not getting too excited or too worried about a super fine surface to the field, the risk of capping and the risk of slumping. So we talked a bit about the ideal seed. And then finally, in terms of establishment, we talked a bit about weed control and the importance of ensuring that, particularly in the first 6 weeks of the maize plant's life, that we've got full weed control to ensure that the maize is not struggling for any competition with weeds. And that graph illustrates that really with yield on the left. And then we've got basically weed control after different periods in the spring. Last week we did a webinar focused on maize for different markets, and we started talking about why you might want different kinds of maize. So we talked about high starch percentage maize and high starch yields, which I suspect Hefin's going to talk a bit about later, so I won't steal too much of the thunder. We talked about the impact of reducing seed rates and the impact that might have on starch levels. And we also talked about row widths a little bit, wide rows, narrow rows, again with the aim of trying to match the maize silage with the demand for it, be it high maize proportion rations or biogas or the like. Then really to see when I wanted to move on to tonight's subject really, which in effect was maize harvest. Hefin is going to talk very much about nutritional aspects of it, so I'm going to focus primarily on the logistics, the practicalities of approaching maize harvest. And I wanted to initially talk about planning for that harvest. We were talking just before we started the webinar that we're amazed how much high dry matter maize silage is made of 35–36% dry matter maize, and that's often the case that maize is matured more quickly than people imagine. So one of the first things I'm going to suggest people do, mid-August onwards, is we do an early assessment of the maturity of the maize. We know we're looking for kind of target dry matters of typically 30 to 34% dry matter. And we know that on average that it dries down at about 2% per week. It does vary when we get to the higher ends of the dry matter, but in that key window, 26 to 34% dry matter, it tends to dry down about 2% a week. And if we're assessing dry matter in August, we're in a position to predict harvest at the target dry matter. So first thing I would very much encourage people to do is to get out there and test dry matter early on. And also, just when you're planning harvest, I would have in my mind the high risk, so the high soil erosion risk, high soil loss risk fields, and I'd be targeting those. And I'd also be thinking about planning my kind of tyres and tyre pressures and wheel choice to reduce the risk of damage. In terms of assessing dry matter, there's no doubt in my mind that oven is best. What I mean by that is use of a garden shredder to completely shred a whole plant. So there's no risk that we have more cob or more stalk in our sample. Lob it in the oven overnight, dry it wet, dry it dry, and we'll end up with a pretty accurate assessment of the dry matter. And as I say, mid-August onwards, that gives you the best chance of getting it right in mid-September. If we haven't got the option to oven dry, then we're into assessing the development of the grain. And this is a chart that has been around for a long while now, but it allows farmers to assess the progress of what we call the milk line up the grain, center of grain in a cob, and depending where it is, you're able to make an assessment down in that yellow line at the bottom of that chart as to the whole plant dry matter. So we're looking for that milk line to be about a third the way down the grain, and that tells me I'm about right, 30, 32. It clearly only looks at the grain. There are some other guidance at the top there in terms of plant colour, but you can't beat the good old oven. Last slide really in terms of harvest was just starting to, I hate to do this, but to plan for the worst, dealing with difficult harvests. And I think, exit and entry points of the fields are really important to think about. If we can avoid channeling water down to the bottom gateway, that's going to help. We need to think about stubble post-harvest cultivation, ideally on the day of harvest, but as soon as possible afterwards, and particularly relevant to gateways and headlands. And we also need to think about, in the worst case scenario, silt fences, sediment traps, and again, think carefully about tyres and pressures. This picture actually is taken on a farmer up near Shepton Mallet. Anticipating a wet harvest, he decided he was going to harvest his maize into the cleaned out dung spread, as I hasten to add. And the idea was that those dung spread has much bigger tyre footprint on the ground and did a lot less damage than they would have if the farmer had been driving around on conventional tyres. So harvest aside, I wanted just to spend the last 2 or 3 slides talking about post-harvest management. So this is a classic slide that some of you may have seen, but it's an old slide now, but it illustrates a really good trial that was done probably 15, 20 years ago, where you've got 4 different treatments shown in a field. You've got the 1 second from the right, as I'm looking at it, is the stubble with 2 tractor marks across it, the unprotected stubble. The one to the right of it is a cover crop, so it's a crop established after the maize harvest. The far left, you've got undersown maize, so a crop that was sown into the maize. And then the second from the left, you've got a chisel ploughed plot. So it's the bare stubble, but it was cultivated to encourage infiltration. And Steve just works through the next kind of clicks. We'll end up with some data on the different treatments. So do them all, Steve, I think, because I think it's hopefully we'll play ball at the end there. Yeah, so you go back one if that's possible. Yeah. Oh, perhaps not. Try one. Nope, can't. Okay, so I'll describe it. So if you go back to the picture, Steve, and I'll explain where we are with that, with the photograph. So in effect, the runoff off that chisel ploughed plot was 1 litre for a set amount of water. So it had the least runoff compared to the 4 treatments. The highest was the bare stubble, the compacted stubble, which collected 228 litres. The cover crop improved it down to 179, and the undersown improved it a lot by 53, down to 53. But the chisel ploughing, the cultivating bare maize stubbles works in most circumstances, it allows the rainwater that falls on that stubble to be absorbed and released slowly. So if you do nothing after your maize stubble in terms of cover crops or undersowing, most certainly think about chisel ploughing, particularly those compacted areas. Just bear in mind, if the ground's super sodden, wet, you can do more damage than good, so pick your chance. I always argue if you can cultivate, if you can harvest, you can probably cultivate on the day. It does nothing to do with nutrient though, unfortunately, chisel ploughing, it just holds the soil in the field. So the next slide really illustrates what can be done in terms of cover crops and nitrogen leaching. So this is actually a crop following winter wheat, but it illustrates an important point, I think, that what you've got on the left of this graph is you've got the total nitrogen leaching in kilograms. You've got a red line at the top, which is the average for the bare stubbles. So 47 kilos of nitrogen was leached. And then along the bottom, you've got 3 different crops: oil radish, Italian ryegrass, and spring oats and Felicia. You've got, and then you've got 2 different sowing dates. The green block is the first sowing date, the 22nd of August. The second sowing date was the 29th of September. And what you can see really is that both sowing dates of cover crops dramatically reduce the nutrient leaching, but the earlier the sowing date, the better. And though the oil radish, for example, virtually eradicated the leaching compared to the bare stubble. Why is that relevant to maize? Well, it's relevant to maize because one of the things we've learned a lot in the last 4 or 5 years is that undersowing maize, continuous maize, clearly, if you're following with a crop, that's not possible, but undersowing maize most certainly addresses the nitrogen leaching challenges that can sometimes be the case. It also reduces soil loss. So I'll finish off, Steve, with my kind of final slide, which is oh, in fact, jump that one, Steve. I ditched that one on my presentation, so we'll go straight to the last one if you can. So really, that's an illustration of undersowing working well. So that's, in effect, you've got a green crop on the right there, grass in this case, soaking up nitrogen, soaking up anything else that might be hanging around, holding it on over the winter, ready for either destroying by a Roundup spray, or even better by grazing sheep or young stock, and they'll convert that grass into really useful manure ready for the next crop of maize. Much better than that left bare maize stubble. So I'm going to finish there and hand back to those with the power, but I'll be around for questions later if anyone's got any questions on what I've said. Thank you.
Thank you so much, John. No, that's fantastic, and we're already getting some questions through, which is great. In fact, we've got a comment, I think it's relevant, she's talking early and late harvest, that somebody has said it's amazing how powerful it can be if you have somebody on a JCB with a road brush at the time, and you keep people informed in the local Facebook groups. It actually gets a huge amount of goodwill just by explaining what you're trying to do. So I think it's always good to work with folks. John, you're on mute if you.
Yeah, I have. It's a good example, Steve. I have a client who pre-maize harvest every year, goes around the village and handing out leaflets explaining what they're doing, why they're doing it, and they'll have cars move for them. There'll be people watching gates. It's a tremendous exercise. Brilliant.
No, thank you, John, for your time, and thanks for that comment there. Any questions we've got for John, we'll put to John later on in the question and answer session. So next we'll go to Joe, and Joe, if I can ask you to put your camera on and your microphone. We're going to go slightly off piste here because I wanted Joe just to explain a little bit about his farm over in Chippenham in Wiltshire, how he farms, how he thinks, and perhaps some of the challenges that he's started to have from a forage and maize perspective. So Joe, over to you.
Evening, everybody. Yeah, my name's Joe Carter. I farm in partnership with my parents down in Wiltshire. So we're a herd of 300 cows. We're on a Mondelez contract supplying milk to Cadbury's. Yeah, so Steve's got a nice slide there. 300 Holsteins. We have got some brown Swiss in there, which is my wife's salt, but they seem to fit in the herd pretty well. 240 followers. So the herd is housed all year round, and we calve all year round. We've been housed for probably 8 years now, which the cows made that decision as much as we did, really. I think the way we were pushing the genetics, and the farm isn't really suited for grazing, so it just seemed to fit everyone and the cows better to house them all year. We're yielding 10,500 litres on average now per year. We have been higher, but we've eased back a bit because we're trying to reduce concentrate feeds, and we've got quite a young herd now because we've got a lot of heifers coming through, which I think is pulling the herd average down. So the farm size is, we own 260 acres and we rent a further 60 acres historically, and this year we have just taken on another 100-acre block, which we've got a relationship with an arable farmer that we're having 100 acres on rotation on his farm. So yes, that should make us self-sufficient in forage from now on, I'm hoping, because previously we have been buying a lot of forage in because we've grown cow numbers over the last few years up to 300. And yeah, so all the grounds is used to grow grass and maize, and we have really focused trying to grow as high quality forage as we can, again to reduce that concentrate usage and improve margin. Yeah, is that okay, Steve? Do you want to go to the next? So yeah, so the cows, we split our cows into 2 herds. We don't split for yield, we split for size and dominance. So we have some older buildings where we house all the first lactation cows and second lactation cows until they're PD'd in calf, and then if we're tight for space, then move into the bigger cows. We find it's a real advantage because we are calving the heifers now at 24 months. They are a lot smaller than these 6-7-year-old cows that are, yeah, big as anything. The cows seem to be getting very big, so they don't get bullied as much, and just trying to reduce the stress for those heifers and reduce the chance risk of injury as well. When they come bulling, they're not getting jumped by bigger cows. So yeah, Steve's got this, the map of the farm. As you can see, the older sheds, that's where the existing farm is, and as we've expanded over the last 10 years, we've got a new cubicle shed, which is they're bigger dimensions in there, so they're a lot better for the bigger cows as well. So over the last, sorry, I just touched on that, the new milking shed. Over the last 10 years, we've borrowed quite a bit of money to build a new parlour and new shed, and we bought some land that came up near us, so we are very heavily borrowed. And then going on to the transition cows onto the farm. So we transition cows, we've got 3 sheds we run, and what we do is we transition about 10 to 12 cows at one time and fill 1 shed, and then the aim is to do that on a 3 to 4 week cycle around those 3 sheds. So that group of cows will enter that transition calving pen as 1 group, and then they will all calve. They'll spend 3 weeks in there, and then they should all calve. The shed will get cleaned out, and then it will get filled again just on a rotation like that. And we like this just because it reduces the stress on the animals. There's no social changes, and it guarantees that those sheds are getting cleaned out every 3 to 4 weeks, so they're staying clean. The only downside of this is at the moment the heifers and cows at this, the in-calf heifers and cows are going in the same shed at the same point, which is a bit of a weakness, but I feel that doing this system outweighs the positives of splitting them up. And we try to keep stocking rates low, so they've got plenty of space in there, so the heifers should still be okay in there. Oh, yeah, there's another picture of the feed fence for the transition cows. That's the same map. So those transition sheds are where, oh, there you go. It's just come up, just at the top there, which is also good because it's on the entrance of the farm, so there's lots of people that drive by it. So if there is any problems, they get spotted pretty quickly. So the heifers, so we are a closed herd. I think we've got about 240 heifers on the ground. We've got a lot. We've got probably too many heifers than we need actually at the moment. It's probably a nice problem to have. But so they are closed herds, and their contracts. So we're taking them till about 5 months old. Then they go off to the contract rearer, which we've got a linked holding with, and he's in the next village along, so it works really well. It's close. And then he will rear them, they'll be served over there, and then once they're PD'd in calf, they come back home. And yeah, so they come back into a loose yard. We've got quite a big group of in-calf heifers, and then from that group we'll pull them out. We've got within the old buildings where the milking heifers are, we've allocated a line of cubicles there that will move the in-calf heifers before they go into transition shed into those cubicles. So they're on the sand cubicles. We find this a real advantage because it gets them used to the cubicles, it gets them used to the yard that they will, and socialising with the cows that they're going to be socialising with prior to calving, and we run them through the parlour release once or twice a week. So when those heifers then proceed to go up in calving shed, they calve. Once they calve and come through the parlour, they're used to that experience and used to the yard and the cubicles. Again, just trying to reduce that stress for that animal, because there's a big, those heifers have got a lot of change to cope with, and we do find that quite successful. Yes, so yeah, as I was saying, that line of calves you can just see on the map, cubicles, sorry, just there. Yes, so this is our maize clamp. We've got 3 clamps in total. We use one for one for grass and 2 for maize. We try to make the best size we can. We'll have a meeting with the contractor prior to foraging season to go through everything with him, and Roy will be heavily involved in that. So we'll review what we did last year and set our ambitions for this year. And yeah, I think there's the next slide, isn't there, Steve? It shows the clamps better. Oh yeah, so the challenges we're facing at the moment, we are still getting a bit of unwanted waste on the clamps. We will they run a loading shovel, and we always have a second tractor with wheels compacting the clamp. But we do still find when we start overfilling these clamps that the edges, they're just straight vertical walls, so the edges still aren't getting rolled properly, and we do get a little bit of wastage. We do use silage stop on the oxygen barrier on the clamp, which we find very effective. But what I also find with that is when we put it on, then we use side sheets and fold them over. They do tend to, when you come to cut them off in the winter, they do tend to pull away from the edge. I think where we're putting the nets on top and people are walking on it, it just moves it away from the edge, and that again, that shows where it hasn't been rolled. And so that's something we're trying to look to minimise. We rented a further 30 acres this year just gone, so we had a lot more maize. So we did end up overfilling. We cut the maize in 2 halves. In this second half there was a lot of maize left, and we did overfill that clamp. We had no choice really. We had to just keep going up, but I'm a bit skeptical about when we do open that clamp, because I think we're going to get we'll see a lot more waste on this clamp than we did the other one, just because by the time they're pushing up that high, the edges were not getting rolled. They were literally just going up in a single track by the time they got to the top. So this other clamp you can see is our grass clamp. It's got an earth bank one side and a concrete wall the other side. The trouble we've got with these are the old existing clamps. The first picture you saw is the newest clamp we built, where we corrected the slope of the fall of the floor, so the water runs away. But the 2 old clamps we've got a real problem with is they fall the wrong way, they fall backwards. So when it rains, they fill with water. Though we try and get rid of that water as soon as possible, it does sit there. If we can't get it till the next day, it sits there. And I think you can see on the clamp where it is contaminating the bottom of the grass. It's not ideal. But we did recently have a meeting with Hefin, who you hear from later, and Roy, our nutritionist, on farm. And yeah, they came up with a good suggestion of moving that grass into clamp 3. You'll see the bird's eye view in a second. Moving the grass into clamp 3, where the floor falls the right way. So then we're putting the maize in pits 1 and 2. So when we're feeding the grass, there's less water, because we feel the grass is at higher risk than the maize. And then feeding clamp 2 of maize first as well. So we're trying to feed the maize. So we're trying to feed, clamp 1 of maize during the summer, when we're going to get less rainfall, just to try and reduce that risk of the water contamination.
Lovely, Joe. No, that's terrific. No, thank you very much. You've got a few questions that have come in there. and I will ask one of them now, actually, Joe, if I may, because I think it's very relevant. What do you discuss with your contractor, and do you set targets? And what happens if they don't do what you discuss?
Yes, we'll sit down, and we also, so it's Roy, our nutritionist, also our agronomist there as well. We have, so we'll discuss cutting dates, and yeah, we will go through protocols. We don't set standards as well. We obviously express the standards we want, but we don't hold them. What was the term you used? Sorry.
Oh, so what targets do you set?
Targets. Oh, yes, targets. So we will set targets, but if they don't meet those targets, we won't. Yeah, we don't hold them to account as such. I think there's so many variables, isn't there? You are in the hands of the gods with the weather and stuff. But just I think having that meeting, getting the contractor on board, just to know what he wants you to achieve is really helpful. And he can also relay it back through his team to all the drivers to know what we're trying to achieve.
Excellent. No, thank you, Joe. And actually, I interviewed Roy for a podcast just a few weeks ago. That's available. And Roy was talking quite a lot about the meeting that you had on that subject. So, yeah, I'd urge anybody to go back and have a look at that. We referenced Joe's farm quite a bit in that particular podcast. So thank you, Joe. We'll have more questions for you toward the end, but we'll move straight across to Hefin, if that's okay. And Hefin is going to talk to us a little bit more about the technicalities of maximising value from field to feeding. So thank you very much. Over to you, Hefin.
All right, good evening all. Thank you, Steve, for the introduction. And yeah, we'll sort of try and take it really focusing on, we've got the crop in the field, the decisions we make around harvest, and then really, as Steve said, looking to maximise the value of that crop from field to feeding. And I think this is an area where there's a lot of variability between farms as to how they value the crop, how they treat the crop. And I think I'd go as far as to say that potentially the easier it is to grow maize, the less it's valued sometimes on farm, whereas when we move to more challenging areas further north, very often it's valued more and perhaps treated a little bit better. So there's a lot of challenges, a lot of farms in terms of storage facilities, etc. But again, I think it's something to be very aware of, particularly when we're looking at the cost of purchased feeds. So really going to try and take the crop now from the field through harvest through to the point of feeding. So I think, from a nutritionist point of view, well, why do we grow maize? What are the advantages of maize? Well, it's a palatable, high energy forage. It's got high yield potential, 35 to 55 tons of dry mass per hectare. It's a great starch source for cows. You can get good yields of starch. It's rumen-friendly starch. High potential digestibility from the non-grain part of the plant as well, and that's something I think which is often overlooked. We tend to be very focused on the starch, but we need to look at the whole plant digestibility, and obviously the cow is going to eat every part of that plant, the leaf, the stem, and the cob. It's a really great complement for grass silage and high protein crops and grazing, of course. So it's a really useful product to have on farm. And it is really about trying to then maximize its value and the return we get from it. So touching on what John was saying earlier as well, I think sometimes we have farms where there's perhaps slightly different aims, or perhaps we should have different aims. For example, it could be maximum dry matter yield. I've got clients with very high stocking rates and limited land, so yield of forage per se, whether it's grass or maize, is very, very important. So when it comes to choosing varieties, agronomy, etc., they really are looking to get maximum dry matter yield. Other farms, perhaps where there's limited suitable maize land but ample grass area, then the starch content is more relevant and more important. So again, that might influence variety choice and things like seed rate, as John touched on earlier as well. Maximum whole plant digestibility becomes more important as we increase maize content in the diet. So that's much more important if we're feeding 60-70% of the forage dry matter as maize, compared with a situation where we're perhaps only feeding 20%. And then early harvest, again, that will come in and be very much more critical in some farms and some areas than others. More marginal areas where there is tending to be higher rainfall, more challenging soil types, and of course, depending on the environmental issues and any following crop plans. So it's important to actually think what you're trying to achieve, what are your aims, before you even start to grow the crop and make the growing decisions, let alone the harvest. So the value of maize, this is quite an interesting one, because I think we can quite easily calculate the cost. Maize being a sort of a finite beginning, middle and end crop, all completed in one season, it's relatively easy to actually calculate the cost of the crop. But I think what we've got to try and look at is the value of it. So the value is somewhat different to the cost, and hopefully the value is significantly higher than the cost. So if we took the total cost of growing the crop divided by the tons that we've utilised, then we get back to a cost per tonne. So that's relatively easy to do, and it's typically in the region, I would say, of 110 to 150 tonne of dry matter, and that's very much yield dependent. So if we're in a high yield potential situation, good land with the right variety, good agronomy and nutrition, then the cost does tend to plummet as a result of consistently high yields and good quality. So in terms of value, and I think this is where I'm coming from when we're starting to look at things like utilization, wastage, dry matter losses. If we actually start to try and value it, well, what I've done here is sort of put together a combination of purchase feeds to give us a similar analysis to good quality maize silage. So I'm looking at 32 dry matter, 11.5 ME, 32 starch with an NDF around 40. So just looking at what we could buy in and actually combine to give us that same analysis. So the second column here is, I've called it maize substitute. So I'm using some crimp maize, which currently is getting on farm for just over £200 a tonne. Soya hulls, some fibre, some chopped straw, effectively to dilute it back down and put in some of the lower grade fibre, and then water to bring us back to that sort of 32 dry matter. So you'll see there the first column being maize silage, the second being this sort of formulated substitute, taking bought in feeds, and we've got essentially the same analysis, same sort of dry matter, same ME, same starch, and virtually the same NDF. If we were to combine those products that are there on the market currently and do that, we end up with a product which is £80 a tonne. We would typically expect maize silage to have cost us in the region of £40 a tonne. So its value, I would argue, is significantly higher than its cost. And that's where we really do need to make sure that we capitalise and make sure that we get as much of that crop into the cow and turned into milk or beef. So it's exactly the same. The issue is exactly the same, whether it's milk or meat. What we're trying to do is convert that crop, get it from the field into the clamp, into the animal, and into a saleable output. So, that just highlights where we look where the purchase feed market is. If we try to combine something to replace maize or replace maize that we've lost due to wastage, etc., that's the kind of potential cost we've got. So maximising maize silage value, I'm going to go right the way back to the field and the decisions that we'd make in the run up to harvest. So as John said, monitoring the crop, assessing it, and really trying to hit this sort of sweet spot. And I would say aim for 32, 33 dry matter. So we're very much on the same page there, plus or minus 2%. We're going to have some variation between fields, etc., and we're not always going to get the contractor on the very day that we'd like. But that's really where I think we should be aiming. Personally, I don't see any value in having crops routinely above 35% dry matter, and equally, we don't want to see crops harvested much under 30% dry matter either. We can look at cob and grain assessment. That's traditionally how we've done it, but as John said, whole plant dry matter testing does give us a much more robust and comparable figure. It's a lot more data driven. If we look at the whole plant dry matter, shredded and weighed and dried, then we've got a better assessment than looking at the grain, because if we're only looking at the grain, it does depend then what the grain to plant ratio is, and we can just get skewed a little. So once we've sort of decided when we're ready to harvest and the harvesting team arrive, I think it's really important to communicate with the harvester operator, because I've got countless examples over the years of where things have been done, and then it's like, well, it's too late because they've chopped it shorter than we wanted to, or they've chopped it longer than we really wanted to, and it really just comes down to communication. So I think, you know, when they arrive on the farm, you know, communicate with the harvester operator regarding stubble length, because, you know, that might be something you want to do differently. Chop length, the importance of complete kernel processing, and that's something we're really going to get into some detail on a bit later on, and additive handling and application rates. I've come across situations where, on one case, additive was put on at 3 times the recommended rate because it was a different product to what they normally used, and the communication again wasn't as it should have been, and there just wasn't the understanding of how it needed to be applied. So communication there will ensure that you get your crop harvested as you want it harvested. So then clamp filling, obviously very, very important. We want to fill it with even layers, non-stop consolidation, overnight sheeting. Again, try and avoid that brown line that we see across so many clamps. Consolidate the top, seal with oxygen barrier sheets, cover and weigh, and then wait. Ideally, and this is always contentious because everybody's chomping at the bit, wants to start feeding the maize, particularly if they've run out or they've run short. But ideally, maize should not be fed the year that it's grown. And that's something we're going to come on to a bit later as well. Analyze and formulate the diet. So once you've got the maize in the clamp and you're ready to start looking towards feeding it, then it's worth getting a good analysis done and then start to formulate a plan. And it's, you know, it's about looking at individual diets, but also you know, managing usage in relation to stocks, and in order to give you the sort of the best return as to when you feed it and what animals you possibly target it at. Manage the feed out to maintain a nice clean face with minimal rainwater ingress. So again, the better the face management, the better the rainwater management as well, because we won't get as much rainwater going in, skewing the dry matters and interfering with day-to-day feeding. So coming back to this sort of harvesting at the right stage, well, how critical is this? We're aiming for 32 plus or minus 2%, 33. If we harvest green, immature crops, well, we've got poor starch development for a start, because as the crop matures, it converts sugar into starch, leaves start to die back, and the dry matter starts to come up. So if we harvest an immature crop, we'll have poor starch development, which is lost potential, because the starch is an important component and it's something that's valuable to us from the point of view of feeding the cow. So if we harvest immature crops, we are losing starch and we're losing potential feed value. We'll have a high sugar content and a low dry matter at harvest. This will tend to lead to a low pH and a high acid load forage. So, you know, this might not be a big issue if you've got dry, mature grass silage, but if you've got high quality grass silage, particularly if it's perhaps slightly lower dry matter than target, then the last thing you want is acidic maize further adding to that acid load. So, you know, getting this maize to harvest at the right stage is very, very important. The other point, again, environmental and from a feed loss point of view, you do run the risk of effluent. So crops that have been harvested in the sort of the 20s, high 20s dry matter, far more at risk of effluent, particularly if they're chopped short. And obviously maize harvest tends to be fairly quick, so we can get quite a sudden release of effluent on immature low dry matter crops. So I think if you review, if you're consistently failing to get above 30% dry matter in your maize, I think you need to review the reasons why. Perhaps look at variety choice, look at agronomy, and also look at harvest decision making. It could just be that you just harvest too soon and you should wait a week or 10 days. Could be, maybe it's a matter of looking at varieties, seed rate, you know, your agronomy, fertilizer plan, and potentially if you're happy that all of those are where they should be, it is possible that perhaps maize isn't the crop for you where you're based, and you would be better looking at alternatives, because, you know, we want to get it at its best, and if we consistently fail to get above 30% dry matter at harvest within a reasonable window, then I think it's perhaps time to review the role of maize on that farm. So at the other end, we've got the excessively mature crops. So these tend to be very high starch. So that's you know, if your eye is drawn to the starch content on the analysis, you think, oh, that's great. So very mature crops will be higher starch because they've laid more starch down. But the starch degradability, which means how much of that starch is available in the rumen, has reduced, but also the total digestibility of that starch. So we're far more likely to get starch coming through in the manure and therefore lost. So, you know, it's great from the point of view of analysis. There's a lot of starch there, but ultimately the animal may not get as much of that starch as we would like. The other issue with very mature crops is that we'll tend to have lower whole plant digestibility. So the rest of the plant has become quite woody and lignified. The stem is becoming increasingly woody because the stem's job there really is to hold the cob up. The leaves have died back. And the combination of this can actually give us a lower dry matter yield because the plant is actually just dying back and really just putting everything into the grain. We've got a high risk of fungal disease, which is an increased risk of mycotoxins in the forage, which is not good. It's going to be difficult to consolidate. And then we've got a much higher risk of spoilage at feed out, but also in the TMR as well. So, you know, it'll be starting to heat up and deteriorate on the face. Then you put it in a ration with other feeds, mix it all up, and you'll find that the stability of that ration in the feed trough will also be compromised. So, you know, it is really about trying to hit this sweet spot. We don't want it too green, but at the same time, we don't want crops that are excessively mature. In reality, the variation is quite incredible. Trowell Laboratories, who are probably the biggest silage lab in the UK, provided me with the data for all the 2021 maize that they've analysed to date. If you look here, the green column is the 2021 average. The white column is the minimum result that they've had. The red is the maximum, and then the grey is the 2020 data, just for comparison. So you'll see the green and the grey pretty consistent, both at around that 32. So on average, maize growers are hitting this sort of target dry matter at harvest. However, we've got one down here, which I think was about 16, which is essentially soup. And then at the other extreme, we've got crops that were harvested at virtually 50%. It was 49 point something percent. So incredible variation there from 16 to 50% dry matter against a target of 32, 33. So, you know, it just highlights how much variation there still is with too many crops harvested sub 30 and too many crops harvested at 40% and above. Starch content, again, on average, generally looking at sort of 30, 32, a little bit better in 21 than 20. And remember, starch percentage is also sort of linked to yield. So if we've got particularly big crop, we might get a bit of dilution of starch where, you know, the rest of the plant is actually effectively diluting the starch down. So the starch yield might be there, but the percentage might be affected a little bit by the yield. So the higher starch crop there, over 40%. So I would suspect that that is a crop that's overly dry and overly mature. But then at the other end, quite incredibly, a crop that was down at 9% starch. So, you know, in reality, growing maize and ending up with a product at 9% starch is pretty pointless. The next sort of set of numbers there, or columns, are the level of bypass starch. This is the amount of starch predicted to actually go beyond the rumen and be utilised hopefully by the cow directly and not end up in the manure. But again, you know, quite a big variation. The average being around the 7%. You know, the high extreme up in the mid-teens and the low on the very immature crops down at about 1. ME, well, maize is a pretty consistent crop, but again, you know, the poorer crops down under 10, most of the crops coming in at about 11.2, 11.3, and the very best up at just over 12. MDF, which is our neutral detergent fibre, so again, you know, excessively mature crop, very, very high fibre at the extreme, but generally sitting just under the 40, which is what we'd expect and what we'd aim for. And then potentially very low NDF on a crop perhaps which is very starchy, or at the other end of the extreme, potentially very, very green. Lignin then, which is effectively the woodiness. So again, we'll see that in the very mature crops, very high lignins. Lignin is not of any value to us nutritionally, so we want to keep that lignin level low. But again, quite a big variation there, really mostly coming down to stage at harvest, I would suggest. This is the maize that Joe's feeding at the moment. So I'll just quickly run through this. So dry matter 29.3, so probably just a little bit lower than target. Protein 8.7 as a result of that, probably a little bit more protein than we'd expect to get perhaps if the crop was left a week, 10 days later. Very good D value. ME is good, so suggesting good sort of overall plant digestibility. So, you know, a crop that was highly digestible with a reasonable amount of starch. pH relatively low, again linked to the lower dry matter, so it's produced a bit more acid. If we come down to the starch, 27, so below target really on starch. We'd like to see that certainly the top side of 30, ideally 32, 33. So again, probably suggesting that this crop was not quite at the optimum stage at harvest and probably would have benefited from leaving another week or so. But aside from that, the numbers are pretty much in line with what we'd expect. NDF of 40, the lignin low, it's sort of 1% there, it's 10 grams per kilo, but a sort of a higher than usual lactic acid content for maize, linked back to the dry matter and the fact that there would have been quite a bit of sugar in that crop at harvest. So, you know, generally probably, you know, a good all-round maize, but I would suggest probably would have been better left perhaps another week to 10 days if that was an option. So coming back to the harvester, decisions to be made at the point of harvest, or stubble length, sorry. You know, what are you aiming for? Are you looking to maximize your dry matter yield because you're worried about forage stocks, or are you looking and thinking, right, we've got a bumper crop here, and we're going to actually leave a little bit more of this woody stem in the field because we don't need the bulk. We want to actually try and concentrate it up. So remember, the feed value on the bottom of that stem is very low. You know, it's very, very lignified, very fibrous, you know, very strong, because that's what's holding the whole plant up. So again, it's worth communicating with the harvester so that he knows that you either want to get as much bulk in the clamp as you can because you want to make sure you don't run out, or equally, if you're short of clamp space, then it might be better to actually leave a little bit more of that bottom stem in the field and concentrate up the starch and the ME of the better quality material. Chop length, again, big variability between what individual farms really want. Certainly if they've been on AD work, they'll be running at very, very low chop length. And I've seen crops that have been harvested for cows with very, very short chop length, purely and simply because the harvester has just come from an AD plant and they've just carried on. So again, you know, talk through with the nutritionist, what is your target chop length? You know, we'd say typically 12 to 22 mil. Most crops probably harvested at somewhere between 15 and 18. Consider things like consolidation and the available space. So if you're concerned about consolidation, if you've got a big clamp and you know you're going to have quite a wide face, then, you know, shorter chop will ease consolidation. It will pack in better and you'll have a lower risk of aerobic spoilage. Equally, if you think, well, it's a big crop, space is perhaps a little bit limiting, again, just reducing the chop length a little will tend to help you get a little bit more in the space that you have. Look at the dry matter. If you are harvesting crops in fields which are perhaps a bit below target dry matter, there's no harm in going to a slightly longer chop. That will tend to sort of reduce the risk of effluent flow and just give a little bit more long fibre to counteract the acid load. And equally vice versa, if you go into a crop which is excessively mature and has died off, then that really does need chopping short so that you can consolidate it as well as possible and also maximise the sort of surface area for the rumen bugs to try and break down the fibre. So dry matter can be a sort of one of your deciders in terms of what's the optimum chop length. Rumen health, well, there's always a big debate on this one because in sort of simple terms, we'd say, well, a slightly longer chop will be better for rumen health. However, in a TMR, this could lead to more sorting, and therefore sorting will tend to make rumen health worse. So it's really about looking at the diet, looking at how you're going to feed it, and whether you can sort of hit that sweet spot of having it long enough to give some good effective fibre, but at the same time not have material which is going to be prone to sorting and therefore negatively impact on rumen health. Kernel processing, well, this is the big conversation to have with the contractor and the harvester operator, because it is absolutely critical. The number of crops where we see incredible amounts of lost potential due to kernel processing issues. So harvesters have got better over the years, but it does come back to the machine. It comes back to the setup of the machine, the level of wear in the processor, and you know, the real understanding of how valuable it is in terms of maximising the feed value from the crop. So that's something we're going to come on to in a minute. Additive management, so again, just make sure that they understand what the target application rate is and how you're going to manage the logistics. So again, you know, make sure that you keep them replenished and that they fully understand how much you're trying to put on. While you're at it, it's probably just worth mentioning the desire to try and get the crop in the trailer as well, if at all possible. So kernel processing, we're aiming for 100% processed grains. And I think going back a few years, and I've been feeding cows now for the best part of 25 years, and we used to tend to think, oh, it's got a crack in, that's good enough. I would say now it needs to be smashed and not just cracked. There's no end of work that's just shown the value of well-processed grains. The utilisation is better, the feed efficiency is better. And if we've grown the crop and we've invested in the crop, what we don't want to do is lose potential at this point of harvest. So we really are looking for, the aim is 100% processed grains smashed and not just cracked. Very simple test at the point of harvest, and there's a few other ways of assessing it, but this is a pretty simple one really and fairly quick. You just take a 1 litre cup, they tip a trailer up in the clamp, scoop up a litre cup of loose maize. It doesn't need to be packed in. You're literally just scooping it up and taking a litre cup. Tip it out on a sort of a clean surface and then count any whole or half grains. So your target is less than 2. Some would say the target is 0, but I think if we could get to less than 2, then we're nearly there. So it takes 2 or 3 minutes to do. Literally 1 litre cup, loosely filled with maize. You can do the same out of the clamp, but obviously at that point there's not a lot you can do about it because the crop is in the clamp and that's it for another year. But if you do it when the trailers are tipping up, you can at least then, if there are any concerns, you can be on the phone or speaking to the harvester guy and just saying, look, we need to sort this out. We've got to try and get this processing better. And it's something to do not once, but do it several times during harvest as you move from field to field, just to pick up any issues at that point. Because if the crop gets in the clamp with poor processing, there is nothing that anybody can do about that for the rest of that season. Repeat during harvest, like I say, as fields and varieties change. So this was one I did back in the autumn. Basically, we did this was coming out of the clamp. This wasn't at the point of harvest. The suspicion was that it was really bad, potentially one of the worst I'd ever seen. So that's what a litre of loose maize out of the clamp looks like. And you'll remember I just said there our target is to have less than 2 whole or half grains. So 2 halves is 2. A whole 1 and a half is 2. So that's our target in that 1 litre. That's how many came out of that sample that I've just shown. I'll save you the job of counting, it's 45. Surprisingly enough, when we looked at the dung, it was absolutely full of unprocessed grain. The lost potential on this crop is just horrifying, absolutely horrifying. The maize had got great potential, it was a great crop, you know, plenty of starch there, good grain fill, harvested at the optimum time, analysed well, absolutely fine, no issue, but feeding terribly. Milk protein struggling, cow condition struggling, despite the fact that what was on paper was going in as high quality maize. The problem being the cows could not utilise the starch and therefore the true feed value was very, very low. So the only time to really be in a position to rectify that is at the point when the crop is being harvested. So I would urge you to really have a close look at grain processing when the crop's coming in. There's a lot of good work come from the States on looking at the impacts of kernel processing on fecal starch, or starch in the manure. So this is some work Cumberland Valley Labs did. They use a mechanical sieve to sieve out the samples, so it's very, very repeatable. And then they assign a kernel processing score. So they'd say anything less than 50 is inadequate, anything from 50 to 70 is adequate, and 70 and above is optimal. So we're really aiming to be consistently, I would say, above 60. So what they did, they took samples from however many farms are on that, however many columns are on there, but then they also, in addition to doing the kernel processing score, they also took dung samples and looked at how much starch was in the dung, fecal starch. So you'll see the blue is fecal starch and the red is kernel processing score. So the ones on the left of the screen have got a really good kernel processing score, the best one there up at about 75 here. Very, very low level of fecal starch. At the other end, we've got kernel processing score of, what's that going to be, 35, so really poorly processed crop, and 10% fecal starch. So, you know, what this showed very, very clearly was that if we process the grain effectively, we get very little starch in the dung. And that doesn't always, it isn't always about seeing whole grains or part grains. It is even just very small starch particles which have come through as a result of the breakdown being too slow. So very, very clear indicator there of the impact of kernel processing on how much starch is in the dung. And if the starch is in the dung, it's of no value to the cow. So essentially all of those samples there were coming into the below 50 or the inadequate kernel processing score. And you can see that's probably 40% of the farms that they looked at. So when we're looking at fecal starch, I mean, if you've looked in the dung and you see grains and you see parts of grains and you see little sort of flecks of starch, you can see it sort of quite clearly here. Even, you know, there's grains there, there's part grains, but there's also little sort of light coloured starch particles there. So on this particular sample, it was 12.5%. This one here, which looked like a really good dung sample, it was 0.32, so virtually no starch in there. There was some other US work which looked, again, you know, obviously high yielding cows in the States, high maize diets, but they quantified that to a 1% reduction in fecal starch was worth 0.33 kilos of milk. So, all right, we're not in America, we're not perhaps necessarily feeding at the same levels of inclusion that they might, and we're probably not running at the same yields. So even if we took a 75% relationship there and said, all right, in the UK, we're not going to have quite those sort of numbers. We'll work on 75% of that. And we'll also make the assumption that if we process it well, so good kernel processing, we'll get a 6% reduction. So the difference between those two pictures is effectively 12%. So what I'm looking at is 3/4 of the response and sort of getting to a halfway house between those two. The maths on that works out at 1.5 kilos a day more milk. So what it's saying is, if we reduce the fecal starch by 6% through better kernel processing, we can expect 1.5 kilos more milk. And I wouldn't argue with those figures, having seen well-processed and poorly processed crops in the field. So putting some numbers on that, if we've got 42 tonnes per hectare of ensiled maize, if it's at 33% dry matter, that gives us 14 tonnes of dry matter per hectare. So that's maize in the clamp, fermented, ready to feed. If we're going to feed 7 kilos of dry matter a day, so say a typical 50-50 maize diet, 1 hectare, which is 14 tonnes of dry matter, will effectively feed 2,000 cows for 1 day, or it would feed obviously 200 cows for 10 days. So however many cows we've got, we're looking to stretch that over with 7 kilos a day. So 1 hectare would feed 2,000 cows for 1 day. If we've got poor kernel processing and we've lost 1.5 litres a cow a day on 2,000 cows, fairly straightforward, we've lost 3,000 litres of milk. So when we've fed that 1 hectare of maize, we've lost 3,000 litres of milk, let's say 34p a litre. That's £1,020 per hectare of lost milk sales, and that's just off 1 hectare. So an acre of maize, if we don't do a good job of kernel processing and we lose the anticipated amount of milk, we have lost £400 an acre or £1,000 a hectare of milk sales from that crop. So perfectly good crop in the field, perfectly good analysis, totally sort of driven by the extent and the consistency of kernel processing. So that's a really big one, and I think it's one where a lot of people have got a lot of easy wins really going forward if they manage that situation better. Additives, I'm not going to get into any detail on additive. All I would say is if we're looking to maximise the value of the crop, we want to minimise dry matter losses, we want to minimise feed value losses that occur during fermentation and during feed out. So hygiene, nice clean clamp, well sheeted, etc. Clean wheels, obviously very important. Consolidation, absolutely critical. And I would say the use of a proven additive and a quality oxygen barrier sheet will all help to minimise the above losses. So I think personally, proven, reliable additive is a good investment to really try and minimise those dry matter and feed value losses that we can get. So clamp filling, I'm not going to teach Granny to suck eggs, but we want thin layers, well consolidated. We hear of a target of 25% of the hourly delivery tonnage in tractors just consolidating. So if there's 100 tonnes an hour coming at the clamp, then we're told we should have 25 tonne of combined weight of tractors rolling. I would say we typically see 50% of this, and in many cases we don't. So, it just highlights how much scope there is to improve the quality through more consolidation. Harvesters tend to get bigger, throughput's very, very fast, incredibly fast in some cases. We'd have clamps, with double that amount coming at them. So it's a real false economy not to have that extra tractor, compactor, etc., running on the clamp the whole time, just to give that extra consolidation. So that sort of, again, it's sort of a US target, but that isn't including the equipment that's pushing in. This is just consolidating. So it's some pretty significant numbers. So, but consolidation really is important, and we do see, significant difference in density between the bottom 2 meters of a clamp and the top meter, and this just highlights then, the impact and the importance of consolidating the top, because the density up there will be lower, and therefore we've got more risk of aerobic spoilage. So don't underestimate the importance of consolidation. Quality oxygen barrier sheet. Again, I see people use really good quality oxygen barrier sheets, but they don't seal the edges. So, oxygen molecules are very, very small. So there's not much point putting an oxygen barrier sheet over the top if the oxygen is able to get in all around the sides and at either end. So if you're using a sheet, it's got to be sealed. The aim is to keep the oxygen out. Cover it effectively, watch out for bird damage, and I think it's really important to get up on clamps and check regularly for damage and movement. Sometimes it's just a matter of sort of rejigging the surface, whether it's tires or gravel bags or rubber mats. If the clamp has moved a bit or the wind's caught something, if you get up there and have a look, you can just reset everything and keep everything nice and taut so that the wind doesn't get a chance to get into it. So that's consolidation. Taken to another level, but I mean, I think you could probably ride a bike on the surface of that clamp, and again, tractor with a good lump of weight on the back, really pressing that crop in while they're filling. So once we've done all of that, and this is a really contentious bit, I'd like you to step away from the clamp for at least 8 weeks. Don't feed it tomorrow or next week. What we should be doing is sealing it and walking away, feeding something else, ideally maize from last year. Then we're ready to open it and see what we've got. So the maxim is don't feed it the year you grow it. Why? Well, maize starch is wrapped in a protein called prolamin. It's a sort of a waterproof sort of coating, and the starch is very much wrapped up in this. Rumen bacteria can only break this down very, very slowly. So the likelihood is when we feed freshly harvested maize within the first few weeks, the rumen bacteria will not have been able to break through the prolamine quickly enough to get to the starch all before that grain has worked its way through the cow and come out the other end. So the starch has passed through the rumen and the intestine of the cow before it's fully available. So again, we've lost energy and yield potential. So again, this is another area I think where we've made the investment in growing the crop, we've harvested the crop, we've clamped it, but we're now losing potential very quickly because we're feeding it before it's properly made. It's like making a cake, putting it in the oven, but then taking it out halfway through cooking and eating it. You know, it isn't going to give the same result as if you follow the recipe and give it its full time. So the fermentation process and the acids produced during fermentation will break down this prolamine. So after a few weeks, it's gone and the starch is then available. And we see it year in, year out where new crop maize is fed. I can guarantee, get back on farm in the new year after Christmas, everything's going better. Everybody feels, oh yeah, the dung's better, the milking better, milk proteins are going up. It's not by chance, it's down to the fact that the maize is actually now feeding somewhere close to its potential. So if we can get that starch availability, we've got more energy going to the cow and we've got potential for more milk. So really the aim is to carry over old season maize to feed until December or ideally even January. And I think this is absolutely critical with autumn calvers. So autumn calving herds I'm working with, you know, we have to be bold and generally shut the maize clamp up in the spring in order to carry over a target amount of maize to start feeding to fresh calvers, to start feeding right the way through until the new crop maize is ready to feed. And if we can do that sort of typically 8 to 10 weeks after harvest, we get a very, very smooth changeover. We can change over gradually and we don't get the issues that we get by feeding fresh maize, which, you know, is not ready to feed. And I'm going to show you an actual real farm example from 2 or 3 years ago, which highlighted the issue around doing this. So this was a client I was working with, well, still working with, and 250 milkers, 20 kilos of maize a day, fairly typical diet, and they were performing well. 34 litres a cow, everything was going well. There was a good carryover of maize, which is a great start. The thing was, the farm had got 3 long, narrow clamps, and there was a good carryover of maize, but obviously it was at the back of the maize clamp. So we discussed it and said, well, this will need to be moved. We've got to take it out of the back of the maize clamp and re-clamp it in front of one of the grass clamps. So that was the plan. It was decided, yeah, we can empty that and then obviously put the new season maize and fill up the maize clamp to the brim. For one reason or another, it didn't happen. So I think they just ended up getting a bit busy the day before the maize, and the contractors arrived a bit earlier than they thought, and they just ended up burying it. But well, there we are, we'll just have to feed new maize. So the 300 ton would have given us 8 weeks feed, and that was the plan. So they pulled a bit out for 2 or 3 days and then literally started feeding new maize after about 3 days in the clamp. So first thing that happened was milk yield dropped 3 litres a cow. They went from 34 to 31 litres within 24, 48 hours. Loss of fats then dropped, and then over the next few weeks there was a significant drop in reproduction stats as well. So things have been going pretty well. Cows are milking on target, fats were fine, cows are getting calf. Well, suddenly start feeding fresh maize, wheel fell off, lost milk, lost butterfat, and started to, you know, get more repeats. No big surprise, but it was a real hit. Yields did recover slowly. We sort of played around with the diet. We ended up putting about 1 kilo more wheat in to try and compensate for the maize starch that was ending up in the slurry. So that was obviously extra cost, but it took 10 weeks to get back to 34 litre average in that herd. So on average, over that 10 weeks, they were 2 litres off where they'd been. So that was pretty significant. We sat down when we got things back on track and just worked out what was the cost of not moving, or equally it would have been exactly the same of not having that old crop maize. You know, the really frustrating thing on this particular farm was that year that the maize was there, it was just, you couldn't get to it because it was obviously at the back of the clamp. So we had an average of 2 litre cow a day yield reduction for 10 weeks, which was 140 litres a cow times 250 cows, 35,000 litres. At that point, it was at 30p a litre. 0.45 pence per litre lost on the butter fat on the resultant yield. And then we fed a kilo more wheat for about 8 weeks at 180 pound a tonne to try and compensate for the starch that was just coming straight through the cows. So it's 10,500 of milk yield loss, 2,500 on butter fat, and 2,500 pounds worth of wheat. So a total cost of 15,500 on a 250 cow herd, 15,000 plus of cost, lost potential as a result of moving straight onto fresh maize rather than moving and then having a very gradual changeover. So it just really highlights how the numbers can start to really ramp up. And that obviously was 15,000 straight off the herd margin for that year, and you know, money that was gone forever. Clamp capacity management and losses. Now this is a real sort of bugbear of mine. We've got a lot of overfilled clamps. I maintain 90% of the farms haven't got enough clamp space for the forage that they're trying to produce and store and feed. Overfilled clamps mean poor top and shoulder consolidation. We cannot safely and effectively roll overfilled clamps. It's just not possible. We end up with visible waste. That is always started off at 2 or 3 times the depth that it ends up at. You know, it's like a compost heap. You keep throwing onto the top and it just keeps sinking and sinking. You know, it never overflows. In addition to the visible waste, we've got hidden losses. So we've got lower feed value in the material below that, and we've got the need for removal. Well, this is something which takes time. It's also, there's a certain risk to that as well, because we're up on top of a clamp having to remove material, which if we didn't have the waste, we wouldn't have to remove it by definition. So lack of capacity really does impact on feed utilization. It limits our options in terms of carrying over maize. It limits the options in terms of rationing consistently. You know, a number of farms, we end up, I call the pendulum of swinging from a high maize diet to a high grass diet, really depending on what's where and what we can get to. So I really do think that, you know, if there's a few pound in the budget, that silage camp capacity is a really good investment for many farms, because it just opens up so many more options. So looking, I mean, Joe mentioned earlier, the top left there, that's Joe's clamp. You know, he's well aware it's overfilled this year, and he mentioned earlier, you know, the issues in terms of trying to roll, you know, this material here. You cannot roll what's on there. You know, it's very difficult then to get sort of a good contact between the sheet, and obviously the other issue is once you're feeding that, then there's sort of 2 wind tunnels under the sheet on those edges where the material will undoubtedly have decayed, and then we'll get air moving back along those sides and causing further waste as we get back in. You know, picture below, again, very steep-sided clamp, and again you can see there's waste. The clamp filled sort of as designed, very easy to roll, very easy to consolidate, and therefore far easier to manage and avoid the sort of waste that we see there in the top right. So when we talk about dry matter losses, with any in-soil crop, we're going to get a dry matter loss in fermentation. Our aim is to try and minimize that through consolidation, through the use of an effective additive, keeping the air out, managing feed out. But it's quite easy to end up with a 20% dry matter loss. So when you're busy harvesting maize and trailers are flying around, just remember this slide. You know, the trailers keep coming, but 1 out of 5 just disappears. 4 of them will still be there when you come to feed out. The 5th one is gone. And certainly if there's any issues around the clamp, you know, all this sort of visible losses here, the dry matter losses there, further dry matter losses here where material's fallen off, contamination, and this one here, wherever there's steam, there's heat, wherever there's heat, there's lost energy. So that was an incredible photo of a heap of maize. I've never seen a heap of maize heating like it, but that's definitely one to avoid. I mean, the issue is obviously we have herd expansion, and the process of herd expansion is generally more milk as accommodation and cows to fill it. That's fairly logical. Slurry storage, well, that's a sort of a necessary evil, so that sort of has to sort of fit. Milking power improvements and expansion possibly, that tends to come with more cows. Then probably look at a bigger wagon, bigger tanker, bigger tractor, bigger loader, bigger bulk tank. And then finally we tend to get into the boring stuff like dry cow accommodation, calf accommodation, and possibly then forage and feed storage. So, you know, there's always a long list of potential investments to make. The shopping list doesn't seem to ever get any shorter. But I think forage and feed storage are ones which do, if anything, need to move further up that list, because particularly when we look at the massive rise in the feed market and the corresponding increase in value and potential of the forage that we have. So again, I'll just give you another true story, and these are two true stories. Another farm that I work with, 350 cow, expanded herd, very similar story to Joe. You know, more cow accommodation, all that done, but still working with the clamps that they had previously. There was a sort of a realization that needed more clamp space, costed it out, looked at putting a single wall and a pad of concrete down to give a sort of an open-ended clamp in addition to the 3 long, narrow closed clamps that they had. And the plan was to do that in 2020. Anyway, for one reason or another, it didn't happen. 2020, they had pretty good grass yields right the way through, so there was a lot of grass silage in the clamps, and the maize did well as well. Maize area had increased slightly in line with the cow numbers, real aim to become more self-sufficient, but lo and behold, ended up filling all the clamp space with up to 2 meters above the wall. So really steep sides, you know, absolutely packing in as much as could go into every bit of clamp space that there was. And again, very steep shoulders that were impossible to roll, let alone safely. So, you know, we knew from the point of when the clamps were filled that there was going to be waste. They also had to sell 5 hectares at short notice because there was absolutely nowhere to put it. That was sold at below cost to an opportunistic AD plant owner. And then obviously the rest was there in these overfilled clamps. Well, I estimated that the top and shoulder waste, having done the measurements on the one complete clamp and another half clamp of maize, was somewhere in the region of 200 tons. They had a daily chore of removing waste, which was not much fun really, because there was a lot of it and it was an awkward job to get it because it was on these steep sides, and if you didn't remove it sort of further back, it had the tendency then to drop and contaminate it into what was being fed. We've got the hidden loss of feed value in the next layer, which is very difficult to quantify, but then lo and behold, had insufficient maize stocks and had to purchase 250 tons of maize midsummer, £50 delivered. So the delay in building that new clamp cost 12,500 in that first season. So the happy ending there is the new clamp was built in 2021. All the clamps have now been filled sensibly, and there is 0 visible waste on any of the clamps this year. And that's a really great return on investment. So we had a good look around last week, and we were saying, you know, how different it was just having the right amount of forage in the clamps, being able to roll really effectively, being able to seal them better, and not have to have this job of removing rubbish and throwing 200 tons of maize away. So rations and feeding, well, it's important to analyse the maize. You know, like we look at the figures that were coming through there from Tro, potentially huge variation. We shouldn't have anything like that level of variation, but still we want to analyse it so we know what the dry matter is, we know what the ME, the starch, and can have a good idea what characteristics we're working. If we know it's 27% starch, then we can compensate for that. But equally, if it's 33% starch, we've got potential for some major savings on added cereals. Plan your target feeding strategy. What are you going to feed and when? So, you know, it's always important to look at how much maize is in stock and then really decide when are we going to see the best return from feeding that. So look at the calving pattern, look at the seasonality of milk price, and look at clamp logistics as well. So, you know, there are several ways of getting the best return from that crop by targeting it at the right time. So a block autumn calving herd, I would say categorically make sure that you have enough maize carryover for 2 to 3 months when your calving cows back in. You'll see a far better return than feeding that in mid and late lactation this time around. Balance the maize with rumen degradable protein. Then protein costs have gone astronomical, but if we're feeding maize, it is a given that we need to feed enough suitable protein to balance the diet up, or we won't get the best response. We might need some structural fibre where necessary to sort of manage rumen health, milk quality, and don't forget calcium. Maize is a very low calcium crop. It's generally low in all minerals, but calcium particularly. Bear in mind the amount of calcium that cows are putting in the bulk tank every day. So it's very important when you're feeding increasing levels of maize to ensure that that calcium is supplemented well. Ensure that the daily feed allocation uses maize from top to bottom of the clamp. There will be variation between fields, possibly varieties, and fermentation. So it's very important whoever's feeding understands the importance of always working from top to bottom. So, I mean, defacers do a great job of that, but I mean, you can just see just on that picture, first thing is how lovely and neat the face is, but also when you look, you can see there is still some variation going through. So it is important to try and make sure that whether you're using a shear grab or a defacer or whatever, that you are always feeding top to bottom so that they're getting a consistent mix. The tighter the face, like I mentioned earlier, the better it is in terms of preventing air getting back into it, but also rainwater. The majority of clamps are outdoors and therefore open to the elements. But if we look at this face here compared with that, we're going to have a lot better management in terms of air ingress into the face, but also rainwater as well. So the neater and the tighter you can keep the face, the better it will be in terms of capitalizing the full value of the crop. So I'm just about on time. To summarize, harvest at target dry matter and maturity, 32-33%. Just remember those numbers. Ensure consistent chop and good kernel processing. That is an absolute must. It's got such potential to make or break the value of your crop. Just remember that £1,000 a hectare or £400 an acre of lost milk through poor kernel processing. Use an effective additive, minimize dry matter and energy losses in the clamp and at feed out. Anything you can do to reduce losses, whether it's a better sheet, an additive, more consolidation, it's going to pay back without one shadow of a doubt. Clamp, consolidate and seal well. Don't overfill the clamps. Come up with a plan B. Look at ways of getting round, but really do all you can to avoid overfilling and ending up with material that you can't consolidate. Patience. Optimum feed value is after several weeks, not several days. So try and plan and ensure that you don't start feeding maize too soon after harvest. Analyze and plan rations according to the quality and the stocks of maize that you have. And remember, maize is a medium cost but very high value crop. So minimize losses, maximize utilization, because that will be good for your P&L and also it'll be good for your carbon footprint as well. So thank you very much. I hope you found that interesting and potentially go away with a few thought-provoking thoughts to look at in terms of what you've got in the clamp currently, but also what to do around harvest next year.
Lovely. Thank you so much, Hefin. I don't know how you get so many messages into that. I think it was fantastic, and no sooner did questions come through, but you answered them. So thank you very much, Hefin. I may just, we've got that many questions. I may just ask folks if we might go over time by another 5 or 10 minutes, if that's okay. If everybody could come back on screen, I'll start putting 1 or 2 questions to you. Hefin, you shouldn't have used a cake analogy because It's got me thinking about my dinner now. I'm going to go back to John for the first one. Hefin, you did mention stalk length, but I'm interested just to know if John's got a perspective on this. How much stalk should be left on the plant when harvesting? It's a very broad question. But...
Yeah, it is, Steve. It kind of, what we know is that the higher you cut it, the better the quality of the resultant silage. The base of a maize plant is pretty strong, pretty woody, often very low in dry matter because it's got to hold up the rest of the plant, and that cob is pretty heavy. So the kind of argument, discussions I would tend to have with people is, what are we doing? Where do we feel we are in terms of volume of silage? Is the crop looking good? Have we going to have enough if we take the height of the chop up? If we can, then we will, because we'll improve the quality. If we're short of forage, then we'll keep it down to probably the 3 or 4 inches kind of minimum that we would, or lowest we'd like to go. So it's very much horses for courses. What are you after? Can we go up and get better quality maize as a result?
Lovely, thank you, John. Terrific. I'm going to go to Joe now. Joe, it's a big question. We've seen there's a slightly overfilled clamp there. You've not opened it yet, so we can't see what's behind that. What are you going to do differently next year? Bearing in mind you've got extra maize crop going to be coming in.
Correct. Yes, we are growing more maize next year. And yeah, I think it's gonna be a real problem when we open that clamp. So the options we're looking at is, I don't really think we're in a position cash flow wise this year to approach the bank to build another clamp yet. So in the short term, we're probably going to look at renting another clamp or an ag bag. I think I'm more inclined to go down renting another clamp if we can find a suitable location and clamp that we can do that in.
Lovely.
I would also, that'll give us the advantage of the other point Hefin made is having that carryover for next year, because we feel guilty of that trap of feeding maize fresh each year. So if we could find a separate clamp somewhere else, we could have that carryover that would take us through into 2023.
Brilliant.
No,
No, absolutely.
Yeah, that's, it's looking at all options. It isn't just about automatically building another clamp, but ag bags, they've got a role to play. There's a cost, but then you must always consider the cost of the lost value of the crop and the wastage. So I've got a client who's done exactly that this year. They've ag bagged a couple of 100 tons rather than overfill a clamp, and I've also got others, like you say, that have managed to rent some clamp space on a former dairy farm, and they've got to move that maize back, but again, it's meant that there isn't the waste, and it's a small price to pay really for having more of that crop available to feed.
Thanks, Hefin. That was going to be my next question to you. So I'll come back to you, Joe. There was a question about what you follow your maize with, because you mentioned you get it off early.
Yes, we're on quite heavy ground down here, and we do farm. Some of the maize ground is road work, so we do try to grow an early type that we can get off early, so we can get a good weather window. Which our analysis, actually, it did cross my mind. We took there was a good weather opportunity, and we did cut that maize probably a week earlier than we should have done, because we just didn't want to miss that weather window. Yeah, sorry, okay. What was the question? Yeah.
No, you've answered it. No, that's perfect, because I had another question about why you were trying different varieties, so that perhaps answers that too. It was just to get that off early, and what you were following it with.
Oh, so historically we were doing 2 years maize and then putting a 3-year grass lay in, but now we've just taken this 100-acre block on. We put a lot more grass in at home, and we're going to just grow the maize away, and I think it's quite light ground over there. So yeah, that's a conversation I have to have with the seed rep, what the best. We'll probably do some soil samples and stuff over there, and yeah, make a decision on that.
Brilliant. I've got loads more for you, Hefin, so I will come to you in a second, but because it's related, John, I just wanted to ask you, if you knew you were having a bad batch of weather, you could either go a touch too early or a touch too late. What would be the safer bet?
I'm gonna hedge my bet. I'm gonna dodge the question a little bit like a politician. I'm going to say that I would like to set myself up with the best chance of avoiding that tough patch of weather, which is on average is going to come in October, not in September. So I'd very much set myself up as best I could. I appreciate the weather it has its variation, but I'd set myself up. So I'm drilling my maize early. I'm using an early variety, so I've got the best chance of harvesting it in the first couple of weeks of September. So that's kind of my standard answer. In terms of yeah, it's a difficult one. I mean, I think if I want to grow maize, if we want to continue growing maize for many years to come, I think in that exact example, Steve, I would have to say I'd go a tad earlier, because you know, the environmental eyes are on badly managed maize fields, and the risks are pretty serious long term. So if I was in that difficult situation, I would have to go for 29-30% dry matter rather than the 34-36. Which might be better for that one particular year, but I want to grow maize for 25-30 years, not next 2 or 3.
Brilliant. No, I think that sounds logical to me. Hefin, I don't know if you've got anything to add to that, or is that?
Yeah, no, I'd agree with that. I think because the point is, as we saw there with Joe's sample, you know, it's actually got a very good ME. So we've got, you know, good plant digestibility. We've got a little bit below target starch. And it's going to be a little bit more acidic, but it's still got really good feed value potential. But we might just need to take steps to buffer that acid load and put a little bit more starch in, which we can do. Obviously, there's a cost to that, but there's a bigger danger probably in waiting and then possibly finding that the forecast changes and we have to wait even longer, and then the crop starts to die back, and then we're really chasing it then with a crop that's died with very poor digestibility. You know, a higher starch percentage, not just because there's more starch there, but because there's less of everything else. So I would agree with John. I think, you know, if you're in that situation, as Joe said they were last year, I think it was the right call to make to get the crop in. Very digestible, 11.5 ME. We can work with that. Just needs a little bit more starch with it, and possibly a bit of a help with managing room and pH. But all doable, really.
Terrific. Okay, lovely. And I'll stay with you, Hefin. How important is cell wall digestibility?
Well, you know, I think it's really important that it's another area where I think we're going to sort of develop more as time goes on, because we've got the starch element. That's really important. We tend to focus very heavily on starch, but you know, we're feeding the whole plant to the cow. So if we're looking to improve overall efficiency of feed use, then cell wall digestibility is definitely important, and it's something which, you know, we should be considering. Like I say, as I put in the presentation there, particularly on a high maize inclusion diet. So it'll be more important on somebody, you know, feeding 70% maize diet than at 20 or 30. But again, you know, the starch is important, but the starch is, say, a third of the dry matter. 2/3 is not starch. 2/3 of that plant is other things. So any incremental gains in cell wall digestibility, primarily through plant breeding, is definitely a big win. And you know, we've got a lot more scope to manipulate that through breeding going forward than we have to sort of get more energy from the starch part of the plant. So yeah, definitely one that we will, I think, be focusing more and more on going forward.
Okay, thank you, Hefin. I'm just going to ask 2 more questions. I know everyone wants to get their dinner, so taking samples, it gets expensive. The costs mount up. We should be taking them through the year. When should we be taking samples, and how often do you think, Hefin?
Well, I think, you know, it's about, again, probably just trying to find a happy medium, and it does depend a little bit on how consistent the product is that you've produced. So if somebody's grown, you know, a very limited number of varieties, and in a lot of cases I have clients growing primarily one variety just with a couple of experimental ones, so that they've got relatively good consistency there. They've got, you know, the agronomy is very consistent, all grown on their own farm under their own control, harvested over 1 or 2 days or whatever. yeah, you're going to analyze it and see what you've got, and you're going to do that periodically through. But in that situation, we wouldn't expect to see huge variation or change. We know over time the starch degradability is going to change, but essentially we'd be pretty confident that the overall characteristics of that crop are not going to change dramatically because of the way it was grown and the fact it was perhaps predominantly one variety. If we've got another situation where perhaps we've got 2 or 3 different varieties and maize grown on different land or by different growers, all coming in and being clamped in different sort of areas of the clamp, then I would say that we need to be aware that there is going to be more variability, and we perhaps need to just analyse a bit more frequently to pick up those changes, because we could then see you know, a much more marked difference as we go back through. Particularly, I mean, I've got one client now and they have 2 arable farms growing maize, plus they grow maize of their own. You know, there's a multitude of varieties in there, soil types, fields, and it sort of, you know, there will be more variability certainly between the back, middle and front of that clamp than there would be this particular farm's neighbour who essentially grows 95% of one variety and treats it all the same, and harvests it on 2 days. So yeah, it's just a matter of checking it going through, but you know, there'll be a lot less variability than there would be with grass silage, for example. So
yeah, I was just going to add, Steve, really, I think, yeah, a dry matter assessment or dry matter variation is probably going to be one of the biggest variants, and that's relatively simple to do in the oven overnight, you know, so it doesn't have to be a major exercise or a major cost to keep a very close eye on maize silage dry matter, and that will dictate to a large extent many of the other characteristics. So I think it doesn't have to be particularly expensive.
Yeah, no, I see. No, perfect. Thank you. And I've got plenty of questions, and we will endeavour to answer those, but I'll just ask one more because it's pertinent to the wastage issue. Is crushed rock salt on top? What are your views on the use of crushed rock salt, and if it's a benefit, how much should be used?
Well, I would say it's something which 20 years ago was very, very commonly used. It's become a lot less common, but if it was mine, I would use it. I think it's a very cheap, very effective antimicrobial that you can apply on the top layer. And I think what's tended to happen, perhaps people have moved more to using additives, but I think there's room for both. And I think, you know, this sort of shoulders, they say probably 6 kilos per square metre, top probably about 3, 4. You know, it's incredibly effective. Maize diets are low in salt in any case, so it's doing 2 jobs. You'd be feeding salt with the maize in any case. So if you've put some of that salt on the clamp, it's done a really good job of reducing the risk of mould and microbial growth on the clamp. And then that salt is still there, and it'll find its way into a cow as well. So like I say, far more common 20 years ago than it is now. But personally, I would recommend it, and I would do it.
Lovely. No, well, that's brilliant. Thank you so much. We've got plenty more questions. I've got to let people have their evenings back. So we'll endeavour to answer as many of those questions afterwards as we can. Just to point out that we do have plenty of resources within AHDB, cross-sector resources. They're pertinent to all. So there's maize-specific resources. There's also Forage First book, which is predominantly a dairy book, but again, it's pertinent to all. If you want to take a picture of this page, get in touch with our publications team or our KE team. That would be you can get access to those. And lastly, it just remains for me to thank our 3 speakers this evening for such an informative evening. I've learned a huge amount. And if you'd like to catch up on this webinar, a link will be emailed to you in a few days' time. So if there's any details you want to pick up. But for the other webinars, you will be able to find them in our webinar archive on the AHDB events page. The best way to get to that really is just to Google AHDB events. And please do take your time to fill in the survey at the end of this webinar. I'm sorry we did run over time a little bit, but it does help us with offering our offerings for next time. But lastly, I'd just like to thank you once again for your attention, and please do enjoy the rest of your evenings.